Hello everyone, hope you all are doing well. So in this video, we'll discuss the last problem of Leetcode Weekly Contest 336. It's a hard level problem. The problem name is minimum time to complete all tasks. So the problem statement says that there is a computer that can run an unlimited number of tasks at the same time. Okay, you are given a 2D integer array tasks where tasks of is basically start I, end I and duration of I, indicating that the ith task should run for a total of duration of I seconds, not necessarily continuous, within the inclusive time range start I to end I. Okay, you may turn on the computer only when it needs to run a task, and you can also turn it off if it is idle. Return the minimum time during which the computer should be turned on to complete all the tasks. Okay, what does this mean? So if I pick this tuple, this is 231. So it says that this is the task, this is the first task. Okay, this is one of the tasks and you can run it. Okay, you can run it in a time range 2 to 3. Okay, and it needs to run for one duration. So either you can run it at time equals to 2 or you can run it at time equals to 3, because only one unit of time is needed here, right? Similarly 451. So this task, okay, this task can run basically in this time frame, either at t equals to 4 or t equals to 5, and again it only needs to run at 1 for one unit of time, right? Similarly, what about 152? So 152 means that the third task can run from time unit 1 to 5 at whatever time you want, but within this range, and it needs to run for 2 unit of time. Okay, so now these are the three things. Now at a particular point of time, you can run any number of tasks, so you need to tell the minimum time for which the computer should be turned on to complete all the tasks. So let's see what will be the answer for this one. Okay, let me just erase it first. Yeah, so yeah, so if this is sort of a number line, okay, this is 0, this is 1, 2, 3, 4, 5. Okay, so I can run this task. What about this 2 3? Okay, this needs to run for 1 unit of time. Okay, so either I can run it at 2 2 or 2 3, right? Either I can run it at t equals to 2 or t equals to 3. Okay, so what I'll do, suppose I run it at this particular point of time. Okay, so my computer is on at t equals to 2. So whichever task is basically saying that okay, I can run at in this time range, like where we have a possibility that it can be run at t equals to 2, so that task will also be executed at this time, right? That task will also be executed. So at t equals to 2, only one task, there are two tasks, right? This can be executed at t equals to 2 and this can also be executed at t equals to 2, right? So now what will happen, I'll switch it on. Now this guy will be completed. Okay, this is gone, this remains and this remains. Only 1 unit of time remains for this one. Okay, now what is the second thing? I can switch on my computer at t equals to 5. Now when I switch my computer at t equals to 5, what happens? This guy, the second task is complete, because it needs to run only for 1 unit of time, and this guy also completes. Okay, only 1 unit of time was remaining for this one, so this also completes. So I switched on my computer only for 2 unit of time, only for 2 seconds, and all the 3 tasks were completed, right? So this is what it means. Okay, at t equals to 2, what happens? 1 unit of this task is completed and 1 unit of this task is completed. At t equals to 5, 1 unit of this task is completed and the remaining unit of the third task is completed, right? So you need to tell the minimum amount of time that is needed so that everything is complete. Okay, let's see one more example. So what about this one? 132. Okay, so you have 0 1 2 3 4 5 6. Okay, so what I'll do now, the first task can be run. Okay, the first task can be run within 1 2 3. The second can be run between 2 to 5. The third can be within 5 to 6. It takes 2 amount of time. This 3, this is 2. Okay, now if I switch on my computer for t from 2 to 3, so what happens? This guy will be completed. Okay, for t equals to 2 and this. Okay, this time range at t equals to 2, I can complete this as well and this as well. Now 1 unit of this task will be completed at t equals to 2 and 1 unit of this task will be completed at t equals to 3. So now this is completed and only 1 unit of this task remains. Okay, only 1 unit of this task remains. Now what I'll do, I'll switch on my computer at t equals to 5. Okay, suppose t equals to 5. The remaining task of this is completed and 1 unit of this is completed. So switch on at t equals to 6 as well. So this is also completed, right? So there are 3 units of time. Sorry, there are 4 units of time. 4, 3, 5 and 6, at which if you switch on your computer, all the 4 tasks will be completed. All the 3 tasks will be completed. You can see if you check for the other possibilities, the total time required will be greater than 4. Okay, so this is what the problem is asking you to do, right? So now first thing is how to approach this problem, right? How to approach this problem. So just you need to observe some things, right? Also see the constraints. There are 2000 tasks. Okay, so the constraint is not too much, so probably roughly an n square approach would work here. Okay, that's the first thing to observe. Now the second thing is, suppose you have some task. Okay, suppose you have some task and these represents, suppose this is my number line and there is a task that can be completed within this time range. There is another task which can be completed within this time range. Third can be completed within this time range. Fourth, something like this, and so on, right? Yeah, something like this. So consider the task which has the earliest end time. Okay, which has the earliest end time? This one. Okay, this one. Now if I want that I have maximum number of overlaps, what do I mean by overlap? If I switch on the computer such that it completes the maximum amount of task when it is switched on. So what I'll do, if this is the task, I'll try to switch on my computer during the end time. Okay, during the end time. So because suppose I make a diagram, let me erase it, then it will become more clear. Suppose it is something like this. Okay, yeah, now it is something like this. So suppose this guy needs 2 unit of time. Okay, now if I switch on my computer for these 2 seconds, so what will happen? In this 2 seconds only this task will be able to complete, only this task will be performed. However, if I switch on my computer, instead of switching on my computer for these 2 seconds, I switch on for these 2 seconds, right? 1 and 2. So what will happen? This task will be performed, this task will be performed, and this task will be performed. So switching on the computer for 2 seconds only, but if you switch it at the near the end of start time, only this will be performed, only this particular task will be performed. However, if you switch it at the end, near the end, then there are chances that the maximum number of tasks will be performed, right? So that's the main thing to observe here. Okay, so what you can do, you can simply sort, you can simply start picking the task based on their earliest end time. So what will happen? You will, if this is your number line, you will pick up the task with the earliest end time, and you will try to complete this task starting from this end, right? So suppose this is the first task. Okay, and it needs 3 unit of time. So what I'll do, I'll pick these 3 units from the end. Okay, now when I pick these 3 units, suppose there is another task which is overlapping, suppose something like this, which is overlapping. So 2 units of this task is also completed, right? 2 units of this task is also completed. So now what I'll do, when I'll have to complete the remaining 1 unit of this task, what I'll do, I'll try to perform it from the end of this task, end time of this task. Okay, I'll perform this thing. Now comes the question, how do I know that 2 units of this task is completed? Means while I was completing the first task, 2 units of this task is also completed. How do I know that? So I can simply keep a set of some numbers. So whatever timestamps where my computer is on, I can simply add it to my set. Suppose 4, 5, 6. So 4, 5, 6, I'll add it into my set. Now when I try to pick this task, what I'll do, 4, 5, and suppose it can be performed till 9. So what I'll do, I'll check that is 4 present in my set. Yes, it is present. So now you don't need to, so 1 unit of this task is reduced. You again check, is 5 present? Okay, if it is present, 1 more unit of this task is reduced. Okay, you keep on doing this. So you see that if this is your time range within which you can perform a task, so how many time slots are present in your set? Okay, so if the total number of time slots, okay, is satisfied, suppose the total duration that you need to perform this task is d, and the total number of values in this set is obviously is d. Okay, if it is less than d, that means you need to switch on your computer to complete some units of this task. Okay, so what you'll do, you'll start from the end for this task. Otherwise, you are done. This task is also complete, right? Simple. Nothing fancy needed here. Okay, so that is what I have done in my code. I've taken a set. This set basically tells that at which timestamps your computer was on. Okay, your answer initially is 0. Okay, now what do? You sort your array based on the basically you sort it so that the task with the earliest end time comes first. Okay, so what do? You just see that, okay, if a of 1 equals to b of 1, that means if there are two tasks having equal end time, so sort it based on the start time. Simple. Otherwise, sort it based on the end time. Okay, sorting is done. Now what I'll do, this is the number of tasks I have. Now this is the duration for which I need to run this task, and duration exhausted means that how many unit of time has already been exhausted for the current task. Okay, so or that this particular unit of time was already performed by some other task. Okay, when I switched on my computer for that other task. Okay, so what I'll do, I'll do something like this. J equals to task of I 0 means for the current task, this is the start time, this is the end time. Okay, now start checking. Is your set containing the current timestamp? If it is containing, that means 1 unit of time has already been performed. So if total d durations are there for which I need to switch on my computer to complete the current task, now I only need d minus 1. Okay, so you keep on doing this. See that how many unit of time has already been exhausted within the current task range. Okay, now what do? Once you do this, duration exhausted is less than duration. That means you still needs you need to switch on your computer because some unit of time is already is remaining for the current task. So what do? Answer plus equals to duration minus duration exhausted, because for this amount of time you need to switch on your computer. So you increment your answer. Now what I will do, obviously this is the remaining amount, so just see what I am doing. Start equals to task of I1. I should have named this variable something else, but yeah, what I mean, this is the start time, this is the end time. Now if you want to perform x amount, if you need to switch on your computer for x amount of time, what you will do, you start from this, direction, because again you need to have some overlaps, right? Or you need to have some possibility of overlap. So that is what you're doing. While remaining is greater than 0, if your set doesn't contain the current value, so add it and remaining minus minus and start minus minus. So suppose if I take an example, so 5 to 11 suppose. Okay, so what I'll do, I suppose I need to switch on my computer for two units of time. So what I'll do, I'll check, is 11 in my set? If it is not in my set, add it, and now I need to switch on my computer for one more time, for one more unit of time. Otherwise, if it was in my set, I would have not added it, I would have searched for 10. Okay, and I would have to switch on my computer for 2 more seconds. Okay, simple stuff, basic mathematics, what I told you. And start minus minus, this loops keep on running till remaining is greater than 0. That means you have not completed the current task. Okay, and finally you return your answer, right? So yeah, this is for this particular problem. This was a good problem to solve, to be very honest, but the main observation here was key to have the maximum overlap. You need to sort the task with the like based on the end time. Okay, and then you are good to go. And how to keep a track of this the visited times, so you can keep a set, and since the constraints are 2000, so even an n square solution would work, right? So that's what we have done here, right? So yeah, I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to this channel as well. In case of any queries, mention that into the comment section. I'll revert on each one of them. Thank you, take care, bye bye.